Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be covering 7.4, which is looking at how to calculate the area of a triangle. Obviously we know how to calculate the area of a triangle depending on what information is given to us. We know that, you should know by now, that the area formula for a triangle is typically area equals 1/2 base times height. However, sometimes we're not given the base and the height. So using trigonometry, and there is a way to derive this formula, but using trigonometry, we can figure out the area of any triangle even if the base and height are not given to us. So again, without trigonometry, we know the area of a triangle to be 1/2 base times height. For a triangle where we're not given the base and height, what we can do is, again, a modified version of this formula, and I'll spare you the details since we're trying to keep it brief and precise here, but the area formula becomes 1/2 AB times sine of the angle. That symbol right there is a Greek letter, the Greek letter theta. Typically we use theta to indicate an angle measurement, but it doesn't have to be theta. It could be x, it could be any other variable. So in this instance, if we're using this area formula, A and B are the sides that are adjacent to the angle. So whatever the angle is given, I need the two sides that are next to it to be able to use this formula. So for instance, if I had something like, say I have an angle here of 80 degrees, and let's say this side is 10 and this side is 8. So using the formula, I'm using the two sides that connect the angle and the angle itself. So the area here would be 1/2 times 10 times 8. In a commutative property, it doesn't matter if 8 or 10 go first. And then the sine of that included angle, which in this case is 80 degrees. So once I type that in, then it's just a matter of using your calculator or Desmos, 1/2 times 10 times 8 times the sine of 80 degrees. Remember to make sure that your calculator is in degree form, not radian form, DEG. That gives me an approximate area of 39.392. And of course, if units are given, then you would want to put your area in that same unit measurement, but squared. So 39.392. That's all there is to it. Sometimes you'll be given more information than is necessary. So for instance, if I have, and again, we're not assuming that these are drawn to scale, but let's say 75 degrees, 12, 18, 15, for instance. I could be given more than the information that's necessary for the formula. Remember that what you're doing is you're using the two sides that are adjacent to that angle. So if I'm using 75 degrees to calculate the area, and let's say these are centimeters, then I'm using the two sides that are adjacent to my 75 degree angle. So 1/2 times 18 times 12 times the sine of 75 degrees. I do expect you to write out the formula before you calculate it, just so I can see that you're doing the proper setup. Don't just give me an answer. This is 1/2 times 18 times 12 times sine of 75 degrees. Which gives me an area approximately 104.320. And because this was centimeters and we're talking about area, that is a square unit of measurement, so centimeters squared. Let's do one more. Let's say this is 110 degrees. I have a side length of 10 inches and 22 inches. Again, not assuming that this is to scale. So my area is 1/2 times the two sides times the sine of that angle measurement. Once I write out the area formula, then it's just a matter of plugging it into the calculator. So 1/2 times 10 times 22 times sine of 110 degrees, which gives me an approximate area of 103.366. and this is inches, so because it's area, inches squared. So be sure to put your units, and if the directions not specify a decimal place, you want at least 2, but 3 preferably. That's it for 7.4. If you have any questions, reach out to me. Otherwise, have a good day, and I will talk to you soon. Bye.